Here we go with number 4. A limited edition premium dog food is labeled as sold in 25-pound bags. An investigator is tasked to check this claim. A sample of 30 bags produces a mean of 24.9 pounds with a sample standard deviation of 0.7 pounds. Is there enough evidence to conclude that the average bag actually contains less than 25 pounds as labeled? And we will use alpha equals 0.05. Okay. So we're thinking of ourselves as the dog food investigator. Is this company trying to rip people off? They say it's 25 pounds in each bag. Is that really the case? So I think if we were in class, I would say, hey, they sampled 30 bags and the average came out to be 24.9. Does it seem like they're trying to rip people off? And I would see what you guys had to say. Can't do that. Let's just dive into it. So we are going to assume that they're telling the truth. Okay, innocent until proven guilty. So the null hypothesis is that the average of their bags, mu, really does equal 25. Okay, we're going to need a lot of evidence to show otherwise. Here, the alternative hypothesis, and we get this one by reading the question. Is there enough evidence to conclude that the average bag contains less than? So we use the less than. First time we've seen this here in an alternative hypothesis, that mu is actually less than 25. And I guess, thinking practically, if they put more than 25 pounds in, that probably wouldn't be as big of a deal as if they put less than. So there's our null and alternative hypotheses. Okay, let's move on to step 2, the test statistic. And here the test statistic is, it's going to change a little bit. We're going to use the t-score from the student t. And I'll show you how we can identify that when we read the problem, because it may or may not tell us, right, to use it like in homework and stuff and on a test. So let's take a look. So the t-score, if you remember, I know you're probably looking at it right now. It starts off the same, but then we divide by s over the square root of n, very similar to the way the confidence interval worked. Okay, so here we got to plug in all our numbers, right? So mu we're assuming to be 25. X bar is the sample mean, 24.9. And you notice that in the problem, it says the sample standard deviation is 0.7. So we know they're talking about S, which means we need a t-score. Okay, so let's put all those things in. Oh, looks like I made a drawing. Forgot about that when I was setting this up. So, okay. Oh, I'm going a bit out of order here. Sorry for the confusion. When it's less than, we shade our alpha down below. Okay, so the first example we did, we were shading it above because we had a greater than. We've got a less than here, so we put that entire alpha down underneath. All of it goes underneath. Okay, now we get to step 2. Here's our t-score for the test statistic. 24.9 minus 25 over 0.7 over the square root of 30 bags in the sample. So we can identify that that was a sample standard deviation, so we know to use the t-score. Okay. When we compute this, we get negative 0.78. I rounded that to 2 places, as is typical to do of a z-score and a t-score. That's the test statistic. Okay. Step 3 is the p-value. So let's take a look at that. And you notice I left this part blank. The p-value, the probability that capital T, is it going to be a less than or a greater than? Well, here we can look back at the null hypothesis. Mu is less than 25. So we go with a less than. Negative 0.78. Now at this point, get into your stat crunch, get into your T calculator. Okay. In the T calculator, not only do you put in the value of T, you have to put in the degrees of freedom. All right. So why is the degrees of freedom 29? Well, if you remember from confidence intervals, it's always one less than the sample size. Here our sample size is 30. So we're going to put in 29 degrees of freedom and then put your t-score in there, negative 0.78. And you should get this number right here, the p-value of 0.2202. You know what I think I do? I tend to round these to 4 places unless it makes sense to go further. So I'm pretty sure that's rounded. That's just the way I like to do it. That will 4 decimal places will always be accurate enough unless you get a whole bunch of zeros, and then you might probably want to consider going beyond that. But 4 is generally plenty accurate. Okay, so hopefully you got that p-value. Moving on to step 4 is to compare the p-value with the significance level. Okay. So we were only looking at things below, so we just keep that alpha as it is. Well, which one is bigger? Clearly the p-value is bigger in this case, 0.2202. Okay, that's step 4. Step 5, we call it make the decision. Is that enough evidence to reject the null hypothesis? Should we reject the null hypothesis, or do we fail to reject? And it'd be a lot more interesting if we were in class together. If the p-value is bigger, do you reject or do you fail to reject? Well, if you recall, if the p-value is bigger, we fail to reject. Why is that? Okay, well we've said it before, but where is it? How is it in this context? Okay, so if we're shading that bottom 5%, did this probability get small enough to get into that shaded region? Well, no, because you know that the bottom 5%, this is 22 over 22%, not even close. It's probably somewhere like in here, maybe not even that far, not even close. That came from the sample of 24.9. Of course, there's more things than just 24.9. There's a sample size, there's the standard deviation, but all that considered, that probability nowhere close to that shaded region. So you might argue it's some evidence, but definitely not enough evidence, so we fail to reject. And if you would like the interpretation, it's always good. Some homework questions ask about the interpretation. Most of them do not. In this case, you would say there is not enough evidence that the average bag contains less than 25 pounds. Okay. Now, when you give an interpretation, you know, if it's in your own words, if it's in the homework, it's going to be multiple choice. But if it's in your own word, you don't have to phrase it exactly this way. You know, there's other ways to do it. But being careful to use language like not enough evidence, right? You would not want to say there's evidence that the bags are 25 pounds. You know, like that. We never prove that the null hypothesis is true. Just like in a courtroom, you never prove that somebody is innocent. That's not the idea. The idea is, can you prove they're guilty? And here, do we have enough to reject the null, or do we not? Simple as that. Okay, so here we don't have the evidence. There's not enough evidence that the average bag has less than 25 pounds. I think we're going to go right into practice problem number 5. Let's do it. If you have not read that little bit about proportion-based hypothesis testing, go ahead and pause the video. Do that now. We're going to get right into the next one. Practice problem number 5. Okay. Let's give ourselves some clean piece of paper here. Make notes with. Let me read it. In a particular state, 24% of all lawyers advertise in some way or another. An attorney claims that more than 24% of all lawyers in his city advertise. A sample of 200 lawyers in the city showed that 63 had used some form of advertising. At alpha equals 0.10, is there enough evidence to support the attorney's claim? Okay, so you notice we've got our alpha is a little bit higher, so we don't need quite as much evidence to reject the null hypothesis. That's one thing you can notice. But of course, the big thing is just the nature of the problem. We've got all these percentages, and that makes it the proportion-based hypothesis test. Okay, so when we start talking about the null and alternative hypothesis, you notice we don't use mu anymore. We don't have a sample, or excuse me, we don't have a population average, or mean, probably what I should say. We're not talking about a mean. We're talking about a proportion of success. Success and failure. Okay. So why do we make the null p equals 0.24? Okay, what does p represent? P is the larger population of success. So it says in a particular state, 24% of all lawyers advertise. So we're going to assume what's going on in his city is the same as the larger state. The lawyers who advertise in his city are no different than the lawyers, the proportion of lawyers who advertise in the entire state. So the larger state population has 24% success, 0.24. Okay. Now he wants to know, he thinks, based on his sample, that actually more than that proportion of lawyers really do advertise in his city. So what are we going to say for the alternative? Well, we're going to use his language. He claims that more than 24%. Okay. That the proportion of success in his city is greater than that. All right. Okay, that's nice that it's just the phrase more than is right there in the problem. Not obviously not less than, and not a not equal to. Okay, let's move to step 2. Now step 2 is going to take a little bit of thought here. So notice step 2 is the test statistic. For one thing, notice that it is a z-score, but it looks a lot different than our previous z-score formulas or the central limit theorem for sure. This part may look familiar from the margin of error formula back in confidence intervals. Okay, one big difference is the margin of error had p hat q hat, where here we've just got p and q. Now maybe if we were in class, somebody would ask about that. Why p hat q hat, you know, in the margin of error formula? But here, just p and q. If you're wondering about that, bring it to the Zoom session. when it comes to the confidence intervals, it's just P and Q. And then we've got P again there. So again, there's no mu, there's no sigma, and there's no X bar. It's proportions of success. Okay. So you might wonder, all right, we're going to assume P equals 0.24. 0.24, that P will be 0.24 as well. So what are all the other values? Let me show you. Okay. We need P, Q, P hat, and N. Let's start with the easier ones. So P, we are assuming the proportion of the population is 0.24, which would make Q the complement, 0.76. Take 1 minus 0.24. And that's how you get Q. What's up with P hat? P hat is from the sample. That's the sample proportion of success. Okay. The sample proportion of success. So it doesn't give us this number directly, but it does tell us that he took a sample of 200 lawyers, and he found that 63 had used some form of advertising. Okay. So when the sample was done, we had 63 successes out of 200. 63 out of 200 use advertising. And that comes out to be 0.315. So the proportion of success for the sample, right there. And, you know, the easiest one to identify, N, that's his sample size, 200. Okay. So let's put all that into the formula to get our test statistic. Sample proportion minus population proportion. Then under here, big square root PQ over N. And if you type that in, being careful, you should get 2.48. That's the test statistic. Oh, gosh. Okay. The test statistic, I haven't said this so far in any of these problems, the test statistic is the most difficult step. Because identifying the right pieces, especially for the population, or excuse me, for the proportion based, it's real easy to goof up, even if you put these in right, just to make sure you calculate it correctly, but then let alone each of the parts. The most challenging step right there. Okay, let's go to step 3. Once you have the test statistic, can we get the p-value? So here, with the proportion based, we're back to a z-score. So we're going to use the normal calculator in StatCrunch. The p-value will equal the probability that capital Z, is it greater than, less than? Which one? And we could go back to the alternative hypothesis. P is greater than 0.24. So there it's really key that we get that alternative correctly, that we know how this one should go. The attorney claims that more than 24%. We want the more than. Okay, if we put that into StatCrunch, we can use the greater than, put in 2.48, and you should get this number, 0.0066. All right. Going on to step 4, let's compare that p-value with the significance level. Our significance level is 0.10, rather high. And we got a pretty low p-value there. So here, of course, the alpha is the bigger, easily 0.1 versus 0.0066. No problem. So what does that mean? Step 5, we either reject the null hypothesis or we fail to reject. Do we have enough evidence to reject? If alpha is bigger, yes, we do. Reject the null hypothesis. Here's the sketch, in case you're curious. We assume 0.24 is at the middle. We shade the region alpha, that's above. Did this p-value make it into the shaded region? Oh, you bet it did. 0.0066 is way, it's probably not even long enough. I probably need to extend this out. It's way up here. What was it, 0.315, something like that? From his sample. The chances of him getting this many lawyers out of 200 in his city are tiny. There's the chances of that happening are so small. If this really was the average in his city, then we're just going to say no, that's not the average in his city after all. It's got to be higher. Okay. Reject guilty. What's the interpretation? In case you needed to know that, there is enough evidence that more than 25% of lawyers in his city advertise. Okay.